स्टेट ऑफ मोशन। अपने स्टेट मोशन का स्टेट में रेस्ट या मोशन दोनों को अपोज करते हैं। लाइक इफ देयर इज अ हैवियर बॉडी इट विल हैव मोर इनर्शिया, इट विल अपोज मोर। If you are heavier, you will oppose more. If you have less weight, you will oppose less. If somebody is pulling you, if you are heavier, then he will have a hard time pulling you. And if there is a lighter guy who is having a lighter weight, so he will be pulled easily. So inertia is the property which rushes the change. Okay. So now let us see one more situation. What will happen or what is happening here? The object velocity has increased. It has increased from v to 2v. There would be some force. कोई force होगा जिसने इसकी velocity change होगी because according to Newton this is not possible कि अपने आप velocity change हो जाए, अपने आप state of motion change हो जाए, ऐसा नहीं हो सकता। तो there would be some force, but कहाँ होगा, किस side होगा, direction क्या होगा? So direction of the force is in the direction of change in the velocity. Velocity का direction क्या है? Velocity का change in direction क्या है? From v to 2v, so the direction of change in velocity is in this direction. So that's why the direction of force is in this direction. Force का direction भी यही होगा. Okay, let us see another example. If the velocity of the object earlier is v and finally it is 0, in which direction force is acting? So we have to look for the direction of change in velocity. Velocity is changing from v to 0. That means direction of change in velocity is in the backward direction. So the force will be acting in the backward direction also. So this time force direction is in backward direction. Now let us see another case. Okay, now the velocity has not changed. Earlier situation, now further we have the same velocity, but here what we have, the direction has changed. So can we say that there is a force? Because the value of the velocity is same. Because Newton said that the velocity should change. I am asking the question, is the velocity changing? I will say yes, the velocity is changing. Why? Because velocity is a vector quantity. If the direction changes or the magnitude changes, so that means velocity is changing. Here the magnitude is remaining constant, but the direction has changed. So there is a force acting on it. But in this direction, we have to look for the direction. So in this case, we have to do one more thing to find out the direction. We have to find out the direction of change in velocity. For that, we have to subtraction of vectors. As this velocity is a vector quantity, so we have to perform subtraction of vectors to get the direction of change in velocity, and in that direction force will be acting. So finally we know that if the velocity changes, there might be some force acting on it. But what is the value of that force? वो value क्या है? What is the magnitude of that force? Newton said that force depends upon many number of factors. Like I earlier said that if you are heavier, then we have to apply larger force to pull you. That means your mass is the one factor. So force is directly proportional to m. What is the second factor? Second factor is acceleration. Now what is acceleration? Acceleration is the rate of change in velocity per unit time. So force depends upon acceleration also. Change in velocity or change in velocity per unit time. So what the magnitude of acceleration gives us? It tells us how fastly the velocity is changing. Like अगर हम एक बॉल को स्ट्राइक करें वॉल पे स्ट्राइक करने वाली बॉल की काफी वेलोसिटी थी, लेकिन स्ट्राइक करने के बाद वेलोसिटी एकदम डिक्रीज कर गई। द चेंज, देयर इज अ लार्ज चेंज इन द वेलोसिटी। अगर एकदम से कोई बाइक 0 वेलोसिटी से 50 वेलोसिटी पे पहुंच जाती है, देयर इज अ लार्ज चेंज इन द वेलोसिटी। सो एक्सेलरेशन इज दैट वैल्यू व्हिच टेल्स अस how much increase is there in the velocity, how much change is there in the velocity. So if there is a large change in the velocity, acceleration is large. If there is a less change in the velocity, the acceleration is less. Now the ball example, if you are throwing a ball, velocity gets reduced to 0 after striking the ball, then that means there is a negative acceleration, and negative acceleration को हम डीएक्सेलरेशन भी बोलते हैं। वेलोसिटी डिक्रीज होगी तो डीएक्सेलरेशन, इंक्रीज हो रही है तो एक्सेलरेशन। फ्रॉम these points Newton concluded that there is a second law I should give, that is F is equal to ma. From these 2 points we said F is equal to ma. Mind it that A and F are vector quantities. Now further, force, acceleration, we all know this, but there is one more factor on which force depends, that is the momentum, the change in momentum. Force also depends upon change in momentum per unit time. Now what is momentum? Momentum is the product of mass and velocity, m into v. But what we are looking for? Change in momentum. So change in the product of mv upon time is our force. There are 2 cases possible here. One is the mass is constant, other is the mass is variable. If the mass is constant, that is usually happens, your mass is not changing daily, and that you eat and you just go to bar, and that's the simple process. There is not a big change in your mass, or like your table, its mass doesn't change daily. Okay, it's a regular mass, fixed mass. So we have regular bodies, we have bodies whose mass is fixed. So these are the general cases. Okay, so we will first take the first case, mass is constant. So what we will get, mass is constant, so m into change in v. So we will write it like this, upon time dv, this represents a small change in v, dt represents a small change in time. So m dv by dt, and this is change in velocity per unit time. This can be represented by A, acceleration. So that was the second law. Okay. So force depends on change in momentum per unit time, and finally from this also we get the second law, m is equal to ma. Okay. What will happen if the mass is not constant? It can happen, and this is the case of rockets. In rockets, fuel burns, the mass decreases, mass continuously decreases because the fuel burns. So we have to consider the complete change of the product, change in mv upon time. And one more thing he said, what? That all these laws are applicable only for point masses. So point masses means small points, those objects whom we can consider as points. Just say you are not a point right now, or you may be a point. Let us see कि किसको हम पॉइंट कंसीडर करें और किसको नहीं। सपोज करते हैं कि यहां से एक ऑब्जेक्ट चला, इसके साइज हम 1 मीटर क्यूब ले लेते हैं 3D में, एंड देन इसकी लेंथ हमारे पास 1 मीटर होगी। He goes to a distance of 100 meters. With respect of 100 meters, this object is like a point. So we have to check how much distance it is covering. So हम कितने डिस्टेंस के अंदर हम अपना लॉ लगाना चाहते हैं, हम कितना बड़ा मोशन को स्टडी कर रहे हैं, ये हमें देखना पड़ेगा। बट यहाँ पर तो हम इसे पॉइंट मास कह सकते हैं, बट अगर it is covering 2 meters, so I will not say that this is a point mass. So we have to see with what respect you are looking, यहाँ पर ऑब्जेक्ट का साइज एंड यहाँ पर डिस्टेंस कवर्ड का साइज हमें देखना पड़ेगा। ओके, so these laws are applicable for point masses. But what will happen if the mass is not point mass, if the body is regular, if the body is bigger, like a truck is moving, here the truck has moved only 2 meters or 10 meters like this, then we will take an example here. There is a point A, there is a point B, and this body is toppling down. Here the point B does not move, but point A moves to this place. ये एक ही बॉडी के दो पॉइंट, एक का तो मोशन है, एक का नहीं है, तो फिर क्या, कौन सा पॉइंट लें, इसकी वेलोसिटी लें या नहीं लें, इस पे फोर्स लगा है या नहीं लगा? What we have to do? Newton said, in the case of regular bodies or those bodies which are not point mass, what you have to do, take the center point. You have to take center of mass. We will discuss this thing in future chapters like rotation. Okay, for the moment you have to just consider, if you want to look, you are looking for velocity, then you will look for VCM, और अगर आप एक्सेलरेशन को देखना चाहते हैं then ACM, that is acceleration of center mass, and VCM is the velocity of center mass. So हमारे जो फॉर्मूला सेकंड लॉ बन जाएगा MACM, ठीक है। सो रेगुलर बॉडीज के लिए हो गया। नाउ अब बहुत देर हो गई, आई एम जस्ट गेटिंग एग्री, आई कैन स्लैप यू नाउ, नो आई एम जस्ट किडिंग। Okay, what will happen if I slap you? Fine, no problem, I'm just kidding. What will happen if I slap you now? You will get hurt. Okay, fine. I'm just imagine it. Okay, so you will get hurt, but I will rub my hands out like this, because when I hit you, some force was exerted on you, but at the same time some force was also exerted on my hand also. मेरे हाथ पे भी कुछ force लगा है, तो the force that acted on your face was action, and the force that acted on my hand was reaction. So there is an action and reaction. Newton said no force existed independently. He said forces exist in pairs. So whenever there is a action, there will be a reaction, but in opposite direction. Like slap you like this, the force on your face is in this direction, so the force on my hand is in this direction. And these two forces also act on two separate bodies. So from this he concluded the third law, which is for every action there is equal and opposite reaction.